Okay, so this is our sixth lecture for SAT Math, and today we'll be continuing where we left off in the last class. Uh, First, I'm just going to revise the last part of the last class where we left it. So at the end of the last class, we learned how to interpret parts of a linear function. Okay, linear function we said can be always written in the form of y equals to mx plus c. Okay, where c is y-intercept and m is slope of the line. Now suppose if I've drawn this line, I know that slope of this line is m. Let's take slope to be negative half for this instance, and let's take y-intercept as 5 comma 0. I mean 0 comma 5. Alright, now I want to interpret what these things mean. Okay, the equation of this line will be something like this: y equals to minus half x plus 5. In the last class, we learned whatever x represents, whatever x-axis represents, and whatever y-axis represents in this case. Okay. Now, let's say x-axis in this case represents, let's take an example of price and demand because I've taken negative slope. So what this graph is telling us is, for every unit increase in price, suppose if my price is in dollars, so for every dollar increase in price, my demand is decreasing by half a unit. That's what the slope tells us. Whatever the slope is, it shows increase or decrease of y per unit increase or decrease of x. Alright. Second is intercept, y-intercept here. Again, this is an useless interpretation with respect to this graph, but when my price is 0, how much would demand be? That's what y-intercept shows. Okay, so we should be able to interpret the linear graphs. We had done this question in the last class. Here we rejected the first option because first option we have been given 10 minutes after taking the drugs, whereas in the question x represents milligrams of certain drugs and not the time. If x represented time, then this option would have been correct, but since x represents milligram of drugs in patient's bloodstream, that's why we rejected first option. We just looked at other two options. Now coming to today's class. First thing that we're going to study is exponential function. Now, one very base of exponential function. We have been studying compound interest, simple interest since like ages. Looking specifically at compound interest, okay, what it does. So suppose I deposited $100 in a bank. Okay, bank is very generous, gives me 10% interest per year. Okay, so my start point is $100. After 1 year, okay, after 1 year, my amount with the bank will become $110. $110 because $100 plus 10% interest on $100. Okay, after 2 years, my interest will be my amount with bank will be $110 plus 10% of 110. Okay, so that will come out to be 121.1 and so on. Now if you observe, this is simply 100 into 1 plus 10% of 100. Okay, this you'd observe can be simplified to 100, okay, 100 plus 1 plus 10% of whatever the value is to the power 2 and so on. This amount, same amount you'll get when you do the calculation and so on. In general, after nth year, my amount with the bank can be modeled as 100 plus whatever the percent is to the power of n. Okay, this is very simple exponential function. A graph of exponential function generally goes like this. Okay, graph is like this if my base is greater than 0. Okay, if my base is greater than 0, my graph will go something like this. Such a function is called as exponential growth function. the case that I have taken in this example is exponential growth function. Whereas if my interests were negative, let's say we were talking about population of tigers in India, okay? Population of tigers in India was dwindling over the years. If I were to represent that using exponential function, perhaps my graph will go like this. Over the period, the number of tigers were reducing in India. Such a function is called as exponential decay. Exponential decay. Whereas this is your exponential growth. Exponential decay happens if value of interest, value of the factor is smaller than 1, okay, between 0 and 1, and exponential growth happens if value of the factor is greater than 1. In this example, my factor is 1.1. When I simplify, I'll get 1.1 to the power of n. Okay. Now, do remember, any exponential function, suppose if I say y is a function, any exponential function can be modeled as a into b to the power x. Now, when I take x as 0, let's say x represents number of years. When I take x as 0, b to the power 0 becomes 1, a into 1 is a. Okay, so a represents what's my initial value. Okay, like suppose if I'm talking about capital, what's my initial capital in the bank? If I'm talking about population of bacteria, what was the initial number of bacteria in the culture? Whatever the x is, that represents your timeline. Generally speaking, it represents your timeline. B represents your growth or decay factor. Okay, like if your B was 1.1, that means our growth factor is 1.1. If B was 0.9, our growth factor is 0.9, decay factor is 0.9. Now what I mean by growth factor is 1.1. Suppose if my population was 100, after 1 year, my population will be 100 into 1.1. Basically, whatever the start is, I'm multiplying that with 1.1. So that becomes my growth factor. Every year, population will increase by 1.1 of whatever it was at the start. Okay, whereas decay factor would similarly represents how much my population would decrease, or how much my whatever the thing I'm looking at decreases. Let's take an example of the same. Now, when you're solving this question, just look at the questions carefully, because generally they do not give very lengthy calculation. Questions are very simple. You just need to comprehend what they are trying to tell you in the question. The current population of town is 10,000. That means our initial population is 10,000, and we can see in each of the given option, we are starting with 10,000. If the population P increases by 3.5%, now your population is increasing by 3.5%. That means your growth factor will be 1 plus 3.5%. Okay, so this will come out to be 1.035. So our growth factor is 1.035 because our population is increasing with 3.5%. And population is increasing every 6 months. When you say every 6 months, that means population is increasing twice a year, because in the final result, they have taken T as years and not 6 months. If T was 6 months, then we wouldn't look at how many times a year. So we are increasing twice a year. So 2T becomes our increasing time, okay? And where T is number of, T by 2, because every 6 months, that means in a year. Whatever is the number of years, you'll be dividing that by 2 so as to get factor of 6 months, T years. So in T years, you'll increase, like in 1 year, you're increasing 2 times, in T years, you'll be increasing 2 times whatever the value T is. Looking at both of this, growth factor is this, you are increasing 2 times a year, starting value is 10,000. Whichever option has all of this is our final answer. So we can see that option C has starting point 10,000, growth factor 1.035, and we are increasing at the twice a year, okay, 2T. So that becomes our answer. Generally, they wouldn't give you a very complicated question. Questions would be very simple, as this was. Okay, let's look at another question on the same. Just try this question, and once you get the answer, please write your answer in the chat. So, a car loses its value at the rate of 4.5% annually. Before I'm done with the question, if you're done, please write your answers in the chat box so that we can compare our answers. So a car loses its value at the rate of 4.5% annually. Okay, so this is a decay problem. Okay, our growth factor will be 1 minus 4.5%. In other words, 1 minus 0.45, which comes out to be 0.55. If the car is purchased for 24,500, which each and every option shows, which equation can be used to determine value of car after 5 years? Value is decreasing at the rate of with the factor of 0.55, and we are looking at timeline of 5 years. So here, option B. See if you got your answer as option B. Option B has given us 0.55 as a growth factor or decay factor, and 24,500 is your initial value. See if any of you guys have any questions, any doubts. All right, then the next. On January 1, a share of a certain stock costs $180. Each month thereafter, the cost of share of this stock decreased by 1/3. If X represents the time in months and Y represents cost of stock in dollars, which graph best represents cost of a share over the following 5 months? Now, this could either be a linear graph or it could be an exponential graph. Graph A and graph B are your linear graphs. Graph C and graph D are your exponential graph. Both exponential graph are exponential decay graphs. Even you can see that for linear, it's downward graphs, as the value of stock is reducing every month. Now, a simple way to understand this question, okay? You started with $180, okay? So first we want to see which of the 4 graphs are starting at $180. We can see that each and every graph is starting at $180. The cost of share of the stock decreased by 1/3. If it's decreased by 1/3 after 1 month, okay, your price of the stock should be 180 divided by 3 or $60. We want to see which of the given graph has stock price as $60 after 1 month. So let's see, for the first graph it's not. For the second graph is little over 100. For the third graph, again it's over 100. So only graph D satisfies the criteria because you can see it's $60 after 1 month. Just to be sure, let's also check for the second month. After 2 months, price of the stock will be 130. 1/3 of 60, which comes out to be $20. And you can rightly see that here it's $20 after 2 months. Okay. So that's why option D satisfies. You could have also figured out that this is an exponential function because your initial value was 180. Your stock price was decreasing every month. So suppose if I take n as number of months after the initial period, so 1/3 to the power n is what you'll multiply with, factor being 1/3. So this is an exponential graph. You could have rightly seen that either option C or D would have been the correct answer, and then checking the way I did gives you option D as your answer. Then, yearly growth in number of fast food restaurants in a certain retail chain can be modeled by function f of n is equal to so and so. According to this model, which statement is true? So before I look at the options, okay, Sahil, what does 5 represent here? Sahil?
So what do you mean by that? I don't
Here
understand.
they have said f of n is equal to 5 plus 8n, no? It's a linear model, right?
Yes, sir.
So in this linear model, what does this 5 represent other than being y-intercept? Do you know?
Not sure. Is it the sorry.
Just try it. I think you got it.
No.
No? Archita, what do you think that 5 represents?
Is it the growth and decay factor?
No. Growth and decay factor comes for exponential graph. Presently, you're looking at linear graph, no? If this graph were, let's say, 5 into 8 to the power n, yes, 8 represents growth factor because it is greater than 1. On the other hand, if we were looking at 5 into 0.8 to the power n, 0.8 is a decay factor. But in this question, it's a simple linear function, right? Something like this. Simple linear function. So if I were to map this graph, I'll get graph something like this. Okay, something like this with the initial value 5 and our slope being 8. Okay, to remember for linear graph, when you put n as 0, whatever is left, it's your initial value. Initial value in terms of this question, they have said that n is number of fast. So here x-axis represents x-axis represents our timeline, years, and y-axis represents number of restaurants. Okay, so when I put in 0 year, that is basically when I'm just starting to check this model, when n is 0, I have got 5 restaurants. Okay, so 5 restaurants is the starting number of restaurants. I want to see where it is. So A is not correct, obviously. B seems correct. C and D will see in a moment. Okay, then next, here 8 is a slope. Slope represents that per year, like in 1 year my number of restaurants will increase by 8. In 2 years, number of restaurant will increase by 2 times 8. 3 years it will increase by 3 times 8. 4 years it will increase by 4 times 8, and so on. Okay, if this were exponential function, in that case it will be 8 to the power n. So in first year we would have 8 restaurants. In second year we'll have 64 restaurants. In third year we'll have 512 restaurants, and so on. Okay, so 8 is number of restaurants added each year after the first year. So this is also true, because when we are increasing number of years by 1, number of restaurants increase by 8 because the slope of the graph is 8, or gradient of the graph is 8. So B looks like correct option. Now we'll see why C and D are not correct. The retail chain opened with 13 restaurants. Now, opened with 13 restaurants, that means when you started, your n was 0. When n is 0, you'll get 5 restaurants. So your retail chain opened with 5 restaurants and not 13 restaurants. Y-intercept of the graph of the function shows the year in which retail chain made 0 profit. The model is not about profit. The model is about how many restaurants are we adding over the years. Okay, so that's why this option is incorrect. I just looked at remaining options just so that we understand how linear model functions and how we look at other options with respect to the given question. Of course, in exam, once you got the correct answer, you move on. And you are confident of your correct answer. Next, this is exponential model because it is of the form a into b to the power of n, or b to the power of x. The breakdown of a simple chemical compound is represented by the function so and so, where n represents number of milligrams of the substance that remain at the end of n years. Which of the following is true? 300 represents number of milligrams of the substance that remains after first year. After first year, that means when I put n as 1, I'll have 300 into 0.5 to the power 1, that will become 150. So option 1 is wrong. because 300 represents my starting point. Okay, when I started, how many milligrams of the substance I had, because when I put n as 0, 0.5 to the power 0 is 1, 300 into 1 gives us 300. 0.5 represents fraction of the starting amount by which the substance gets reduced by each year. Yes, 0.5 is a growth, or in this case decay factor. Each year the substance gets reduced by 1/2 of 300. Not each year, because in the first year we reduced to 1/2 of 300 and came to 150. But when I'm looking at my second year, I'll reduce to 1/2 of 150, okay, or 150 into 0.5. So this option becomes incorrect, because only for the first year we are reducing by 1/2 of 300. Yeah, if each year we were starting with this, okay, for the second year we would have something like this, 0.5 to the power 2. So not each year are we reducing by 1/2 of 300, because in second year we reduce by 1/4 of 300. So option 2 is the only correct one. Just mull this question over. If you guys have doubts, either ask them out loud, or you can write your doubts in chat. Or if you want me to go through the question again, you can tell me. Archita, you have any doubts?
Sir, could you please explain it again?
Yes, let's see. So first thing, Archita, did you understand the difference between exponential models and linear models?
Yes, sir.
Also, did you understand in exponential model growth and decay factor?
Yes.
Okay. Now suppose if I take one function y equals to a into b to the power x. Okay. Now, do you see my values of x will start at 0. Suppose x is number of years. X will start at 0. So when I put x as 0, you'll see y of 0 will come out to be a into b to the power 0, or simply a, because b to the power 0 is 1. Right? So that's why we say that a is a starting point, initial value. Okay, always a is our initial value. B is a growth factor or decay factor, depending on what values we are looking at. Keeping this in mind, our P of n was 300 into 0.5 to the power n. Now first option says 300 represents number of milligrams of the substance that remain after the first year. After the first year, that means when I put n as 1, okay, because after the first year, at the starting point my n will be 0. So after the first year n is 1, so I'll get 300 into 0.5 to the power 1, which comes out to be 150. At the end of 1 year, I should have had 150 milligrams of substance left, whereas question is saying that there were 300. So that's obviously wrong. Then what is 300? 300 is a starting point. When I put number of years as 0, that means when my time is 0, I'm just starting with this experiment. So I'll get P of 0 is equal to 300 into 0.5 to the power 0, or 300. So 300 is my initial value and not the value after 1 year. So option 1 is wrong. Next, 0.5 represents the fraction of the starting amount by which substance gets reduced by the end of each year. Yes, this is true, because when I end at first year, so yes, this is 0.5 of 300. When I look at second year, so I'll get 300 into 0.5, n becomes 2, so that will become 150 into half, or 75. 300 divided by 4, 75. So this is half of 150. For the next year, if I calculate the amount, it will come out to be 37.5, which is half of 75, and so on. So that means this is true. Each year, our amount is being reduced by 0.5, and moreover, we can look at the model. Our decay factor is 0.5. Okay, our growth factor is 0.5. Each year, the substance gets reduced by 1/2 of 300. Okay, each year, the substance gets reduced by 1/2 of 300. For the first year, we are getting reduced by 1/2 of 300. Okay, next year, substance does not get reduced by 1/2 of 300, but 1/2 of 150. Then year after that, it will be 1/2 of whatever the value you get, and so on. So because of this, I say that option third is incorrect. Okay, so option 2 is the only correct option. Do you understand, Archita?
Yes, sir.
Okay, so that's how we look at our exponential functions. So see if you have any doubts, any further doubts. All right, so moving on. Now coming to graphs and tables, okay, some part of statistics we'll be looking at, some parts of graphing and charts that we have learned in past we'll be looking at. First is a pie chart. Now here I have made some question, but before I look at this question, do you remember for pie chart we look at a circle, okay? A circle has total 360 degrees in it. So suppose if I'm looking at let's say I want to break this into pie chart, okay? So suppose I'm looking at data which has been given to me 30, 20 and 50, okay, for some value that I'm plotting on pie chart. 30, 20 and 50 represents my data. I want to present this on a pie chart. So what I'll do is for 30 total comes out to be 100. So on a pie chart, when I want to plot this, I want to know what's the angle that I should mark for 30. So I'll do 30 divided by 100, that is the value that you're looking at for whatever you're plotting, divided by total of all value into 360. Basically I want to break 360 into 30 by 100 parts, okay? So this comes out to be 108. So this angle somewhere here, I'll mark this angle as 108. Similarly, I'll mark for 20 degrees. 20 degrees, you'll see, will come out to be 72 degrees. And lastly, whatever is left, so 180 is here, so 180 is left, which will come here. Okay, so that's how you mark, you draw your pie diagram. Now, one thing to note, to mark how many angles or your theta is equal to value of the given article divided by total of all the articles times 360. Okay, times 360 gives us value of the theta, and that's how we mark on pie diagram. This is one way to look at pie diagram. But if pie diagram is already given to us, like here they have given us pie diagram, but they haven't given us in angles, they have given us in percentage. Since it's in percentage, our job becomes so much easier. So data has been given to us in percentages. So question says, if over a period of months student spends $1,000, what was our expenditure on outings? So our outings is here. Outings is 10%. Okay, I want to know total how much amount this came out to be. So 10% out of 100% of $1,000, which will come out to be $100. So $100, that means students spent $100 on outing. This was a simple circle diagram wherein we used our knowledge of ratio and proportion. So S10 compares to 100, 1000 compares to X compares to 1000. And from there we calculate. So this was a simple ratio based on our knowledge of ratio and proportion. So there are two things that you need to see. If degrees are given, in that case use r theta upon 360 value, or if percentage of some other value have been given, then you can solve this question the way I did. Okay, so that was first, pie chart. Next, we'll be looking at bar diagrams. Again, bar diagrams are very simple. We have simple bar diagrams, or there are multiple bar diagrams, subdivided bar diagrams. Generally in exam you'll see simple bar diagrams questions being asked. Okay, in bar diagram it's like on x-axis it can be anything. In our question on x-axis we have got numbers, year, and on y-axis we have got number of subscribers. Okay, but x-axis and y-axis can be anything. Generally x-axis just represents what we are looking at. It can be, population of male, female, and so on. It can be different types of animals which would be named there. So not necessarily numerical values. Y-axis generally represents numerical value for the bar graph. Okay. Reading bar graph is very simple. In 2015, Netflix had 76 million subscribers. In 2016, there were 85 million subscribers. In 2017, 123 million subscribers, and so on. Okay, so by what percent did the subscriber of Netflix increase from 2018 to 2020? So in 2018, we had 140 subscribers. In 2020, we had 205 subscribers. So total increase is 205 minus 140. Okay, how much is the change of subscribers from 2018 to 2020? It's a positive change because value has increased. So that's why I did 2005 minus 140. Divide by. Since I'm comparing with respect to 2018, that's why I'll divide by numerical value of 2018. Okay, and since this is percentage times 100, so that gives me 65 over 140 times 100. Whatever this value comes out to be, that's our total increase or total percentage increase in the number of subscribers. Okay, so we should be able to read bar diagrams, bar graphs. Sometimes there are comparative bar graphs wherein two separate quantities are given on the same graph. Okay, the way you read is, you read each of the bars separately and then compare whichever way they have asked. Like in this case, they could have broken data into age groups, like age group between 18 to 25 and 25 to 50, and there would have been two bars or maybe subdivided bars, but the way to read it is the same or similar. Next comes histogram. Histogram are very important. They are little different from what it is. I have taken a bit of a trickier question, but in exam generally for histogram, simpler questions come. Okay, the difference between bar graph and histogram is, in bar graph, no, x-axis doesn't represent generally anything numerical. It's just what you are looking at. In histogram, both x and y axis represent some numerical relation. In bar graph, whatever the bar shows, whatever the height of the bar is number of whatever value you are looking at. In histogram, okay, there's frequency density on y-axis rather than frequency, okay, and whatever can be on x-axis. Now, do you remember we calculate frequency density by doing frequency divided by class width. Okay, this gives us frequency. Frequency divided by class width gives us frequency density. What we mean by this? Here, class width is from 30 to 40. That means class width is 40 minus 30 or 10. Frequency here is 8. Okay, so that's why my frequency density will be 8 divided by 10 or 0.8. Alright, now when I plot this, okay, let's say 0.8 will come somewhere here like this, 0.8 and 30 to 40. So this bar will go like this. So this is my bar. When I calculate area of this bar, okay, area of this bar, my length is 30 to 40, 10 units, my height is 0.8 units, this will give me 8. So area is equal to frequency for each bar. Generally speaking, sometimes to confuse you, they may change the bar by some factor. Like let's say if they have given this as 8, whereas value written here is 16, that means you have to factor every times by 2. Okay, each value that you get in the area, you'll multiply it by 2. And if there were 4 here, then each value of the area that you get, you divide by 2. Sometimes, but generally I've never seen such trickier questions asked in SET. In math, higher math, they do, but in SET, they don't ask such tricky questions. It's very simple and straightforward question. Similarly, 40 to 45, our class width is 5, okay. Frequency is 20, so 22 divided by 5 will give you 4.4. So we see that yes, height of 4.4 is there. If you were to calculate area of this bar, we'll get 22 again. Okay, So basically, key takeaway of this is whenever you're looking at histogram, your frequency density is frequency divided by class width, but generally question will come the other way around. A bar diagram would be given and you'd be asked to calculate frequency. So do remember, area of each bar gives you frequency of that group that you're looking at. See if you guys have any questions, any doubts. All right. Then moving on. Third, next is our line graphs. Line graphs are, whenever we want to see an increase or decrease of a particular commodity over the years or over the months, we draw bar diagrams. For example, suppose if we were looking at prices of the stock, which we are looking into this in this question, or if we were looking at a sale of a particular commodity in a particular store, okay, so it would have a line diagram, okay, unless you have modeled it other way. Now suppose if in this question were which period gives us the highest increase over the month. So since it's a line diagram, whichever has the highest slope. Now how to determine slope? Do you remember slope is one of the way to find slope is we find tan theta. One is y2 minus y1 divided by x2 minus x1 or tan theta. Now, if I wanted to just see where do I have the maximum increase, in which 2-year period did I have maximum increase, a 2-month period. If I draw a line parallel to x-axis, okay, this is my angle here, this is flat line, so that means there's no increase. Here if I draw a line parallel to x-axis, my angle will be this and my angle will be this. Okay, now I know that tan theta is an increasing function from 0 to 90 degrees. What I mean by increasing function, as I take higher and higher angles, value of tan theta, output of tan theta will keep on increasing. This angle is smaller than this. This is the largest of the 3 angles as can be witnessed. Hence this from May to June we have got highest increase in the stock price. You can also verify this using the formula y2 minus y1 divided by x2 minus x1. Okay, where x2 and x1 are your month number. Take this as first month, second month, third month, fourth, fifth and sixth. Okay, you can verify like that. Generally simple questions will be asked on line diagrams, and whatever we have learnt in straight line graphs, plotting straight lines, will be using that knowledge to solve questions on this. Last is our probability tables. Again, very important. In the last class we learned simple probability. Presently we are looking at probability tables. Now, how to read two-way tables? Okay, first reading this is very simple. Like people reading non-fiction who are under the age of 21 is 2. Whereas if I look at interpretation of this, people reading sci-fi novel who are over the age of 50 years are 5, and so on. Now questions can be pretty interesting. Like first question, a person is chosen at random. A person is chosen at random. What is the probability that this person reads sci-fi novel? Okay, what's the probability that this person reads sci-fi novel? So there are 30 people who are reading sci-fi novel. Total I've got 140 people. So probability is 30 divided by 140. This was very simple probability. So a person chosen at random reads sci-fi novel with probability this, because out of whole population 30 people read sci-fi novel. On the other hand, now suppose if I say a person is chosen from the age group 22 to 50. Okay, I am locking in this age group. So a person is chosen from the age group of 22 to 50. What is the probability that this person reads action novels? So my answer in this case will be 10 divided by 59, because my subgroup was broken. Okay, I said that if I am selecting a person from 22 to 50, that means total there are 59 people. Out of that, how many people read action novels? So 10. On the other hand, suppose if I say, what is the probability that person under the age group of 15 let's say I ask you what is probability of person selected person is under age group 21, given that she reads romance novels. Okay, given that is an important factor here. This is also called as conditional probability. The question, because of given that, becomes similar to what I did first. So given that, that means I'm just looking at this subgroup. Okay, I'm looking at this subgroup. So total, whatever my answer is, it's gonna be out of 45 because I'm looking at population of 45 people this time. Out of this, I want person under the age group of 21. Okay, so out of 45, 15 people are under the age group of 21 who are reading sci-fi novel. Hence, my probability becomes 15 out of 45. Now, understand the difference between the two questions that we saw here. In this question, it was given to us that person reads romance novels, and we wanted probability of that person being under the age of 21. Whereas in the previous question, I asked a person was selected from the age group of 22 to 50. That's why I first highlighted that group and then looked into the action novels. So whichever part of the population that you are looking into, highlight that group and find your probability accordingly. Okay, let's look at questions based on this. All of this which we covered. This is simple circular graph rather than pie. So if there are 72 set math scores between 510 and 560, okay, so 30%, here I'm writing 100%, between 510 to 600, so I have got 72 set math scores. How many set math scores are above 700? Above 700 is X. Okay, I'm doing simple unitary method. 30 compares to 100 as 72 compares to X because, 30 compares to, I don't know the person, so X percent here, I don't know either of this value. So in this question, I'll first try to find out total values. So 30 compares to 100 as 72 compares to unknown value. Okay, so when I solve this, I'll get 30y is equal to 100 into 72. So y will become 100 into 72 divided by 30. So my answer will come out to be 180. Total population I've got is 180. Okay, how many set math scores are above 700? So total population is 180 and I want to know how many people are above 700. So basically this group. How many people lie in this group? Okay, since I do not know what percentage is there, it can easily be found out how many percentage is there. So what, 55, 60, 70, 80. So X turns out to be 20%. So 20% of 180 will come out to be 8 into 36. Did I make some calculation error? This is 24 3s 24 48. Yes, B is correct answer. I had made calculation error previously. B is correct answer. Alternately, you could have straight away found this value. 30 compares to 20 as 72 compares to X, and you could have straight away found the value using this as well. See if you have any questions. Okay, then the next question. The graph shows, this is based on bar diagram. The graph shows number of US household with laptop computers for the year 2010 to 2014. What was the percent of increase in number of household with laptops from 2010 to 2014? Just try this question. So basically, I've got 100 minus 55 divided by 55. Sorry, it's 2010. 2010 is 40. So I'll have 100 minus 40 divided by 40 times 100. Okay, 100 minus 40 is 60. 60 divided by 40 will give you 1.5. 60 divided by 40, 3 by 2, 1.5. Yes, 150% will be your answer. You can verify my calculations. Okay, I simply did how much is the increase from 2010 to 2014. Increase is 100 minus 40, because in 2014 we had 100 million subscribers. In 2010 we had 40 million subscribers. Okay, since the value millions will remain same for numerator and denominator, it would get cancelled. So 100 minus 40 divided by the starting value with respect to which you are comparing, so 40. So 100 minus 40 divided by 40 times 100. Then next, this is your line graph. The percent increase in number of students enrolled in advanced mathematics courses from 2010 to 2011 exceeded the percent increase from 2012 to 2013 by what percent? Okay, so 2010 to 2011. So how much is this increase as compared to this? We want to know how much is this increase. So from 2010 to 2011, so first let me calculate how much is the percent increase from 2010 to 2011. So this is 400, this is 700. So I'll get 700 minus 400 divided by 400 times 100. Okay, this is 2010 to 2011. 2012 to 2013, I have got, this is 300, this is 500. So 500 minus 300 divided by 300 times 100. The first value will come out to be 300 divided by 400, or 75%. The second value comes out to be 200 divided by 300, 2 by 3. So that will come out to be 67%, roughly 67%. 66.66%, which I'm taking as 67. The difference between 2% is 8. So total, when you compare the two percentage, so 2010 to 2011 comes out to be 75%, 2013 to 2014 comes out to be 66.66%, which I've taken approximately to 67%. 75 minus 67 gives you 8-point difference. So which is approximate difference between the percentage. See if you have any questions. Also try solving this question at your end. Verify that you get the same answers. Okay, then the next question. Again, this is based on combination of line graphs. Now, do you remember whenever you are taking two functions together, no? Two different functions like the previous function, there were lots of different functions combined there, just like here. Okay, such graphs are called as piecewise graphs. This is one such example. So the graph above shows the heart rate in beats per minute of a jogger during a 4-minute interval. Over what interval of time in minutes was the jogger's heart rate changing at a constant rate? At a constant rate, as in the value remained constant. Okay, so if you see value remains constant, that means line will be flat, okay, parallel to x-axis, which is here. It was constantly at 80 between 2 and 3. So our answer becomes 2 to 3. just a second. Here, uh, between 2 to 3 minutes, heart rate is constant. It's not increasing, it's not changing, it's constant. Okay, this is your constant heart rate, it's not changing at all. Whereas between 3 to 4 minutes, okay, your slope is constant, whatever the slope is, okay, whatever the m value is, it's constant. That means increase in heart rate is constant. Whereas here, at each point, our increase in heart rate is different, because if I look at slope between this, slope between this, slope between this, slope between this, each of this will give me a different slope value. So heart rate is not changing constantly. Here, heart rate is not changing at all. The value is constant. So on rereading the question, I realized the error. So heart rate is changing at a constant rate. It's between 3 to 4. Okay, but heart rate is constant between 2 to 3. Okay, it's not changing at all between 2 to 3, whereas it's changing at a constant rate between 3 to 4. See if you understand the interpretation of this question, and see also why did I not take the interval 0 to 1, because in interval of 0 to 1 it's not a straight line graph, it's a parabolic graph, okay, or a polynomial graph, because of which I took it not to be constant. At each point I'll get a different slope. The graph above, which shows again the same, the greatest percentage of increase in joggers heart rate occurred over what interval of time? In minutes. So what we want to do is we want to calculate slope of each of the point given. So 1 to 2, 1 to 2, we want to calculate slope of this. Okay, so this coordinates are 1 comma 100, and coordinates of this are 2 comma 80. So the increase will come out to be 80 minus 100 divided by 2 minus 1. So this is decrease. In fact, I shouldn't even have considered this. This is decrease in heart rate, but we are only looking at increase. 2 to 3, it's a constant, so here it's 0. 3 to 4, your interval will come out to be 280, and this is 410. So increase will come out to be 30 divided by 2 or 15. Okay, so here your increase is 15 times 100 will give you 1500% increase, and from 0 to 1 we want to know how much is the increase here. Okay, so 0 to 1 I have got 100 minus 60, that's 40 divided by 1. So highest increase is from 0 to 1 rather than from 3 to 4. So answer becomes D. I essentially calculated slope of each of the values given to me. Slope from 1 to 2 was negative. I discarded it. Slope from 2 to 3 is 0. Presently, I haven't taken that as option. Slope from 3 to 4 came out to be 15, and slope from 0 to 1 came out to be 40. That means highest increase is from 0 to 1 rather than 3 to 4. So answer is 0 to 1. Then next, the cumulative histogram shows distributions of scores that 24 students received on an English test. If a student is selected at random, what is the probability that student will have a score between 71 and 80? Now this is cumulative frequency. Cumulative frequency graph, that means 50 to 60, that's 4. Okay. Now, if I'm looking from 60 to 70, presently this is 50 to 70, 60 to 70, then presently the height is 8, but actual height wouldn't be 8. This height should also come out to be 4, because 50 to 60 is 4. Just think of it like this, okay? This line is 50 to 70, total length they have given you is 8. Out of that, the length of 50 to 60 is 4. That means remaining length should be 4 as well. Okay, so 60 to 70, your length comes out to be 4. Similarly, 70 to 80, your length should come out to be 16 minus 8, that comes out to be 8. 80 to 90, your length will come out to be 20 minus 16 or 4. And for the last interval 90 to 100, your length will come out to be another 4. Okay, so I have broken histogram into 10 points interval throughout and found lengths of each of the interval. Now, if a student is selected at random, what is the probability that the student will have score between 71 to 80? 71 to 80, we have got 8 students. Okay, total number of students given to us is 24. Since it was a cumulative histogram, I broke it into its subparts so that I found length of each interval. And then in the interval of 71 to 80, I have got 8 people. Total, I've got 24 people. 8 over 24 gives me 1 over 3 as my answer. See if you have questions or doubts. Then next, here, the table above shows composition of a co-ed high school tennis team with a total of 40 members. A player who will be selected at random from the team will be given 2 free tickets to attend US Open tennis tournament. What is the probability that the tennis player tickets will be given to either a female junior player, or male senior player? Okay, these two are totally distinct outcomes. They don't have anything in common. So total, I have got 16 members. Okay, to remember, whenever you are solving something like this, just check if there's any interval which is common to both of them, which you may have to subtract. But in this case, the two are very distinct value. So total, I've got 16 people who may get a ticket out of 40. 16 out of 40 gives me 2 out of 5 as a probability value. Just read through the question, see if you have any doubts or any part you don't understand. All right, then moving on. Again, this is part of statistics. First, let's see what scatter plots are before looking at different scatter plot diagram. So suppose on x-axis, I have somebody's or students marks in mathematics, and on y-axis, I've got students marks in physics. Okay, I plot all of this. I plot all of this marks on my graph, and I get some output which looks like this. Okay, this output is called a scatter plot. In scatter plot, we just plot in the values. Based on the values that I have plotted, we draw something called as line of best fit. Presently, we are not interested in how to draw line of best fit because that would be given in your set question. So line of best fit would be given, this is given. Now, when you are looking at line of best fit, okay, either it will have positive slope whenever it's increasing left to right, okay, left to right when you go, if values keep on increasing, you have got positive slope, okay, whereas left to right, if it goes on decreasing, you have got negative slope. If values are very tightly knit, like in this case, values are very close to my line of best fit, in such a case, we say high correlation. High correlation because values are very close to each other. That means it is observed that the pattern that we are observing is clearly throughout our observations, throughout all the data points. So high correlation. If values are very far, let's say some values were something like this, okay, so it would be moderate or low correlation. High correlation, values are very close together. Low correlation, values are far. What I mentioned is a straight line graph. Okay, we were able to see that the pattern is linear. Okay, such linear pattern is called as linear correlation. Just as we have got linear correlation, we have got something called as non-linear correlation, which we break into different parts. So let's see them. In the first case, it's a linear correlation, and it's strong positive correlation, because if I were to draw a line of best fit, no, it will go something like this. And points will be very close to the line. In the second case, still you can observe that there's some pattern here. Line of best fit goes like this. The values are a bit far from this. So either it's moderate or low correlation depending on the data. But since a lot of points are very close, moderate negative correlation. In the third case, if this exact is what we are seeing, it's almost zero correlation, because if values are either, you know, arranged the way they are here, or values are something like this, or like this. In each of this case, we have got zero correlation, no correlation. Basically, change of one value does not affect the change of another value. For the last case, we have got non-collinear correlation. Sorry, non-linear correlation. Okay. This is your parabolic correlation, also called as polynomial correlation. Apart from this, you should also know another very important type of non-linear correlation. It would look something like this. Okay, something like this. This will be our exponential correlation. Logarithmic correlation, I don't think would be asked in your exam. Exponential correlation will go something like this, either like this or like this, one of the two. Okay, either it will keep on increasing or keep on decreasing in this pattern. That's your exponential correlation. Main thing to know is, first two are examples of linear correlation. Fourth one is example of non-linear correlation. And this is your example of non-linear correlation again. Okay, names are generally not asked. Here you have got no correlation in the third case. Graph shows how the value of a stock has increased over time. The line of best fit is shown. The value of stock increased from June 2000 to June 2005 by approximately what percent? Percent increase will be looking at final minus initial and divided by initial. Okay, presently whenever such questions come, no, we are looking at it with respect to the line of best fit and not the data given. Since you have drawn line of best fit, you will be looking at your result with respect to best fit. So June 2005 here. Let me use another color. This is a result for June 2005, and June 2000 is here. Okay, so the difference between the two values we can see is 25 points, 20 points. Okay, sorry, 25 points. So 25 points. Difference between the y values I'm talking about. The reason being, this is 150, this is 125. So difference between the two y values is 25 points. Starting value was 125 because I'm looking at it with respect to June 2000 times 100. So 25 ones are 25 fives are 5 20s are 100, or 20% increase. Another question that's possible in such question is, what is the average increase from June 2000 to June 2005? Average increase, that means over the period of 5 years, how much has there been the increase? So in that case, what I would have done is, I would have seen how much is the increase divided by number of months. Okay, so average increase comes out to be 25 over 5, or $5 per year. Okay, that's your average increase. This is value of average increase, quite distinct from the question. This is your percentage increase. The third type of question is difference between the actual value and predicted value. Line of best fit gives us the predicted value because it has modeled whatever data you have given to the graph. It has modeled a graph based on that. So suppose if I'm looking at, say, June 2010. In June 2010, this is my predicted value. Okay, whatever this is my predicted value, whereas this is my actual value. Okay, so that would be the difference between predicted and the actual value. Do you remember, predicted value comes from line of best fit. Actual value can be observed from the original points, data points that you have placed. Okay, Next is sampling. Sampling is again part of statistics. Uh, First, let's understand what sampling is or why do we do sampling. So suppose if I wanted to study all the students appearing for SAT math, okay, there would be hundreds of thousands of students appearing for SAT math, and I want to look at study pattern of the students, like when did they start studying, how many hours do they study, what subjects or what books are they referring to, and all of this information that I want to gather. Now, for me to go and interview each of these 100,000 students or more, it would be very difficult and time consuming. Moreover, compiling the data, observing the results, and combining all these values would be very, very difficult and time consuming. Also, it would come at a very high cost. So rather than observing the entire population, okay, in statistics, when I say population, population is the group that I'm studying. Okay, when I say population, population refers to the group that I'm studying. In this case, I am studying students who are appearing for SET math. SET math in the current year 2021. Okay, that's my entire population. Now what I do is, rather than studying all of this population, I take out a group of 100 people. Okay, I take out a group of 100 people, and this group of 100 people is called as sample. I'll study this 100 people, and from that I'll infer. A very simple way of understanding this sample is, suppose if a teacher wants to conduct an exam, if a teacher wants to conduct a remedial class. So rather than asking 60 or 100 people in the class what chapter do they find difficult, teacher will just ask 4 or 5 of them that what topic is it that you find difficult, and whatever this people say, based on that she'll say that okay, I want to take a remedial for this chapter, I want to take a remedial for this chapter, and so on. Okay, so that's how we define our sample. Sample is a part of the population of the entire universe, that entire population that you're gonna study. Now, when you're taking up this sample, there is likely a bias. For example, suppose if teacher asked the students who are scoring more than 95% in the class, for which topic are they finding difficult? It is a bit obvious that the people who are above 95% may not have a lot of difficulties with lots of chapters. So that's why they may say that, okay, I'm fine with everything, I know everything. So this is not a very good sample because teacher selected somebody from whom the expected answer was what she or he wanted. Okay, so bias in sample creeps in when we choose our population such that it gives us an advantageous result. For example, suppose if I wanted to ask about how many hours a particular person exercises in a day. So rather than picking up random strangers at the metro or at bus stop, I go outside the gym, and people who are walking out of the gym, I go and talk to them. This is obviously a biased sample because people who go to gym will be working out more hours each day. Okay, so that's your bias. Bias creeps into because of various reasons, but we are not interested in all those reasons because that's part of later study. Presently, you should just know what is bias. Bias is when your population is such that they will give you favorable result. Whatever result you are expecting, they'll speak in that favor of that. Sample is from population, you are selecting a subgroup and you are studying this subgroup. Okay, let's look at a question based on this. Please read through the question. See what answer do you think of before I read it. Alright, so which survey is most likely to have the least bias? Okay, least bias. Surveying a sample of people leaving a movie theater to determine which flavor of ice cream is most popular. Before I say yes or no, I'll just keep this in mind that some people have gone out to movie and you're talking to them about ice cream and not movies. Surveying members of a football team to determine the most watched TV sport. Obviously, these people are going to say that they like football the most because you are asking football lovers which is the most watched TV sport. Surveying a sample of people leaving a library to determine average number of books a person reads in a year. This is not a very good determining population as to how many books they read, because rather than selecting the sample randomly, they selected the people who are walking out of library who are bound to read more books than the average person, generally speaking. Surveying a sample of people leaving a gym to determine the average number of hours a person exercises per week. Again, as we discussed, this is a biased population because obviously these people would be working out more than an ordinary average person. Out of all of this, only the option A is such that there's no bias in there or no obvious bias. So yes, your answer is A. Surveying a sample of people leaving movie theater to determine which flavor of ice cream is the most popular. Let's look at another. Okay. Next comes something called as averages or central tendencies. Okay. Now we are looking into statistics. What we just saw was also a part of statistics. Came under scatter plots and scatter diagrams. Okay. Now averages. Averages are also called as central tendency. I quote this just for your knowledge. Okay. Central tendencies. Central tendencies because generally it is observed that numbers generally are bound to exhibit certain pattern amongst them. For example, suppose if I were to take data of your class and plot them on a chart, okay, results of people in your class and plot them at a chart, it's highly likely that I may get a chart like this with majority of people somewhere in the center. Okay. So this is called a central tendency of a number. This center to which they are going towards, or most of the data is around this number. That center is called as either mean, median, or mode. It is found using mean, median, and mode. When we look at mean, okay, when we look at mean is total of all observation. When I say sum of x, it's total of all observations divided by number of observations. Suppose if I'm looking at frequency based data, then my mean will be summation of x into f divided by summation of f, or total number of observations. What I call here is weighted mean, or suppose if I want to combined mean, okay, I want to find a value of combined mean. So my combined mean is total of first observation plus total of second observation divided by total number of observations. Okay. Now what we mean by total of first observation here, when I do number of people into mean, okay, for each of this observation, you see that you'll get total of all observations divided by total number of observation, which will be n1 plus n2. This will give you combined mean. Okay, weighted or combined mean. Median. To find median, you simply arrange data in ascending order, which is whichever value occurs at the centermost position is your median. Suppose if you are looking at the graph or chart, in that case just see, do n by 2. N by 2 will give you the middlemost value and see which observation is at that position. So for median, simply arrange data in ascending order. Whosoever is at the center is your median. Mode is the most repeating frequency. Most repeating frequency. Sometimes your data may have more than one most repeating frequency. Such data is called bimodal data or trimodal data. Okay, when to use each of this, that's not part of our curriculum presently, because very simple questions would be asked. Next are measures of dispersion, in which we study range and standard deviation. Generally, not tricky questions would be asked on standard deviation. More likely, you'll be looking at range. Range is simply largest value minus smallest value. Difference between the largest and the smallest value. Okay, let's look at question based on this. Also, lastly, effect of transformation on measures of central tendency, basically on your averages and your range. Now just imagine, okay, in your class, let's say on an average, everybody has, say, 3 chocolates in their bag. Okay, each and every student present in your class has 3 chocolates in their bag. So this is your average number of chocolates. Now what teacher does is, teacher gives each and every person present in the class additional 5 chocolates. Based on this, you'll be able to observe that average number of chocolates now rises to 8. Because each of you had 3 chocolates, now every single person in the class has got 5 chocolates. Okay, so whatever the original number was, you'd be able to see that your average has risen by 5. Okay, so basically the thing here that I want to say is, the point that I want to make is, suppose my original mean is x. If I add a to each value of the observation, then my mean is gonna increase by a units. Whereas if I decrease each value by a, my mean is gonna be decreased by a. Just like mean, median and mode will also follow the same pattern. If each and every value is increased or decreased by a certain value, in that case mean, median, mode are increased and decreased by that value. Similarly, when you multiply or divide, your mean will become a times or divided by a of the original mean if you are multiplying or dividing. So basically, whatever you do, you add, you subtract, you multiply, you divide each of the values, mean does exactly the same. Okay, I'm not giving you mathematical proof of any of this. You can just understand this, interpret this logically. For dispersion, especially talking about range and standard deviation, more likely range. When you increase or decrease, okay, like let's say my smallest value is 10, largest value is 100. I increase each of this value by 50. 10 will become 60, this will become 150. Originally my range was 90, my range is still 90. So increasing or decreasing does not increase or decrease my range. Okay, so when I add or subtract add or subtract a particular number to all the observation, all the data points, my range and standard deviations are not affected. But if I were to multiply, let's say I multiply this by 2, I multiply this by 2, this becomes 20, this becomes 200. Originally range was 90, now you can observe range is 180. So when I multiply or divide each value by a certain number, my range multiplies or gets divided by the same number. Okay, so measures of dispersion, range and standard deviation in our case, more likely range, gets affected in the same direction as when you multiply or divide. Basically, we call this as change of order or scale. Change of order affects basically addition and subtraction, does not affect our range, whereas multiplying or dividing, changing the scale, changes the range. Okay, simple question on each of this will be asked, not very tricky questions. So the average of a set of 7 numbers is 81. If one of the numbers is discarded, the average of remaining numbers is 78. Okay, so average of 7 set. So basically my average of 7 set of numbers was 81. Okay, so I'll say 8 is equal to total of 7 numbers divided by 7. So 567 is your original total. Now you are removing one number. Okay, you are removing one number. So total number of observations now left, data points now left with you is 6, and the mean comes out to be 78. Okay, so that means total of observations now, let me call this y, total of observations now comes out to be 480 and 12, 468. All right. So difference between the two data points, I think it's 99. 99, right? Yes. Okay. So the value that was discarded was 99. Basically, I found total of all the observations in case A and case B, and found the difference between the values in both the cases. Go through the questions, see if you have doubts, if you understand my working. Wait, it's 101, no, 99. Then next. What is the area of circle? Area of circle is pi r square. So what is area of circle? Whose radius is the average of the radii of two circles with area 16 pi and 100 pi. So for 16 pi, when I say pi r square is equal to 16, I'll get r square is 16 or r is equal to 4. Similarly here, I'll get pi r square is equal to 100, r square is equal to 100, r is equal to 10. Average of the two radii will come out to be 14 divided by 2 or 7. Area of circle whose radius is 7 will become pi into 7 square or 49 pi square units. So answer is 49 pi. Okay, this is a simple straightforward question. Then next, the diagram shows a graph of students' test scores in Miss Widow's algebra class, which 10-point interval contains the median. So first, looking at the diagram, okay, looking at the diagram, I see that we have got 30 students in the class. Total, I've got 30 students in the class, okay. So if there are 30 students, that means median, the middlemost observation, will be the 15th observation. I want to now see where does my 15th observation lie, okay. So initial two observations lie over here. Then when I look at the interval 50 to 60, okay, when I look at the interval 50 to 60, I've got another 3 observation, okay, and so on. I go on finding. Now, most likely observation for 15th, here I've got 18 observation. So 15th observation should lie between 18th observations and 12th observation, okay. So when I do 18 minus 2, 18 basically 13, 14, 15, 16, 17 and 18 observation lie in the interval 71 to 80 according to this. See if you understand my statement. Since 12 observations are below 70, that means 13, 14, 15, 16 and 17th observation lie between the interval of 71 to 80. That means 15th observation will also lie in the interval of 71 to 80. Hence, the median, the interval that contains median in this case will be 71 to 80. Because our 15th observation is falling up there. See if you understand. In fact, I need not even have found the difference of this because I'm not interested in frequency. I'm just interested where will my 15th frequency lie. So 15th frequency will lie in the group of 71 to 80. Cumulative frequency means the total of frequencies. See if you have questions, doubts. Okay, then next. The average of A, B, C, D and E is 28. Okay. Average of A, C, E is 24. Okay. We want to find average of B and D. Basically, we want to find what is the value of B plus D divided by 2. This is what you want to find. It has been given to you that A plus C plus E divided by 3 is equal to 24 because that average is 24. That means A plus C plus E will come out to be 24 times 3 or 72. Similarly, a plus b plus c plus d plus e divided by 5 is equal to 28. Okay, I'll take 5 to the other side and multiply with 28 there. I'll get 140. I also know the value of a plus c plus e is equal to 140. Okay, now value of a plus c plus e is 72. When this goes to the other side, I'll get b plus d is 140 minus 72, which will give me 68. Okay, but I want to find value of b plus d divided by 2, so I divide both the sides by 2. I get 34 as my final result. So the average of b and d is 34. You would have observed that I did not look at this question from the perspective of the options. The reason being, even with the options, I would have had to do as much calculations or similar amount of calculations to get there. Instead, I found mathematics simpler. Then the next question. Okay, so with this we are done with our statistics part. There's one small part which I want to teach from statistics. Again, it's very low probability, but since I had observed a question appearing from it once, I'll be discussing that. Something called as box plot, but that I'll cover later on when I cover additional topic in math. Okay, so with that we are done with the third part. Now looking at the fourth part, passport to advanced math. A lot of things that I'm going to cover here, you guys already have studied them. For example, rational exponents, you studied this in your lecture 1 of SET when you studied laws of exponents or indices and questions based on that. Okay, so over there you learned simpler exponents, but I believe you also looked at different types of questions on exponents. Algebraic methods, you already know how to solve them. When I show you the question, you'll understand what I mean by that. Complex number is something new which I'll go through in a moment. Completing the squares, parabola and its equation is also something new which we'll be looking at. And reflecting and translating the function graph. Again, you have learnt a bit of this but not a lot of it, so which we'll cover. First two are known topics. Complex number doesn't delve much into detail. Very simple part of complex number is there. You should just be able to identify that much. Completing the squares, parabola and its equation, we'll see. And how to reflect and translate function, that also will be seen. I'm not giving you laws of exponents because that were already given to you in past class. Presently, I'm just looking at questions based on this. Okay. I'll be looking at this question in detail as well as with options so as to save time. Now, first thing is, I see that power here is negative. Okay, exponent here is negative. Since exponent is negative, that means all the three terms which are currently in numerator will go to denominator. Each and every one of this term will go to the denominator. From the option, I see that there's only one option wherein all the 3 points are in the denominator. That's why my answer is A straight off. That being said, we won't always be this lucky, hence we should also know the mathematical method. So we know that A into B to the power m is same as A to the power m multiplied by B to the power m. We also know that A to negative exponent can be written as 1 by A to the power of positive exponent. Third, we have also learned that A to the power m to the power n can be written as A to the power m over n. And lastly, when you say fractional exponent, that's equivalent to taking mth root of that number. Okay, since my fractional power is m, so mth root of that number. Do you remember mth root of number is distinct from m times root of that number. Okay, so when I want to solve 9x square y to the power 6 to the power minus half, this will become 9. First thing is to make power positive, I'll do this 1 by 9x square y to the power 6 to the power of positive half, which will become 9 to the power half, basically root of 9, that's 3. X square to the power half. Okay, 2 and 2 multiply, cancel each other out, you're left with x. Y to the power 6 to the power half is y to the power 6 by 2, which will become y to the power 3. So 1 by 3 xy cube is your option A. That being said, all of this was not needed. We figured the question out with the options. Next, 4 to the power y plus 4 to the power y plus and so on. So basically, see, just imagine of this like this. How many 4 to the power y's are here? How many times 4 to the power y is repeated? Okay, so I've got 4 times 4 to the power y repeated here is equal to 16 to the power x. Do understand, do not make this error that 4 to the power y plus 4 to the power y plus 4 to the power y is equal to 4 to the power 4y. That's wrong. 4 to the power 4y is essentially 4 to the power y multiplied by itself 4 times, because when we multiply this numbers with the same basis, we add up our exponents. Whereas if they are being added, we add the coefficient. So coefficient of each of this 4 to the power y is 1. So there are total 4 to the power y. So I get 4 times 4 to the power y is 16 to the power x. So I get 4 to the power y plus 1 or 1 plus y is 4 square to the power x. So I get 4 to the power y plus 1 is equal to 4 to the power 2x. Since the bases are same, I can compare the power. So I get y plus 1 is equal to 2 to the power x. Y becomes 2 to the power x minus 1, or my option A. Okay, the property that I've used from this step to this step is a to the power m times a to the power n is a to the power m plus n. Moving on to the next question. Now, whenever you're solving this questions, basically question has said what is 2 root of x minus 3x minus 6, which value satisfies this? Square both the sides and then solve the quadratic equation that you get. That would be very time consuming in this case. So that's why we are not doing that. Moreover, if you were doing that method, squaring both the sides and solving, make sure after that, since the square root, you replace each of the value and check if they are satisfied. Okay, if they are satisfied, as in negative value should not prop up inside the root. Okay, so what I'm going to do is first I'll replace 4 inside the bracket, like I'll replace x as 4. So I'll get 2 root of 4 minus 1 is equal to 4 minus 2. 4 minus 2 is minus 2. This can't be answered because root always gives us positive value. So option A and option C get cancelled. Okay. Option B will also get cancelled. The reason being 3 minus 6 is negative value, but left hand side will always gives us a positive value. So option B gets cancelled. Option D is correct. So let's verify if option D is actually correct. So 12 minus 3 gives us 12 minus 6, which is 6. 12 minus 3 is 9. Root 9 is 6. 6 times 2 is 12. 12 minus 3 is 9, root of 9 is 3, 3 times 2 is 6, and I'm getting 6 is equal to 6, which is true. So option D, 12 is correct. Next, the polynomial this is equivalent to which of this? Simple case of factorization. Okay, one way to look at this is, go on and factorize this, which I'll show you. Another way is you can solve this question using the options as well. X equals to 9 makes this 0. So just put x as 9 and see if you are getting 0. Also, easier number, x equals to 2 makes this 0. So put x as 2 and see if you are getting 0. If you are getting 0, that means either option A, all of them have 2. So we would start with x minus 9, putting x as 9. If it satisfies, we got the answer. If it doesn't satisfy, you can go on and put x as perhaps positive 3. So either one of these two will be correct options or both of them will get cancelled. Alternately, we can do it using normal factorization method. So when I'm factorizing from both of this, I observe that x square is common. I take x square common, I'll be left with x minus 2. From the remaining two, I take minus 9 common, I'm left with x minus 2. So I get x minus 2 as the common part between both of them and x square minus 9 as the remaining part. X square minus 9 can further be factorized as x minus 3 times x plus 3 using the identity a square minus b square is equal to a minus b times a plus b. Okay, so our option B is correct. Also, when I equate each of these polynomials to 0, like suppose I equate b to 0, I'll get x is equal to 2 or 3 or minus 3. These are called as roots or zeros of polynomial. Again, you have studied this in one of the previous classes. What happens at roots is, suppose if my graph is going something like this. In this case, graph will roughly have some pattern like this. Okay, so this will be 3 comma 0, this will be 2 comma 0, and this will be minus 3 comma 0. Those are called as roots or zeros of the polynomial. Then next, how many different points on the graph does the function intersect the x-axis? That means basically question is asking us how many roots of this function exist. So when I factorize this, I take x square common, I'll get x minus 2, plus I take 1 common, I'll get x minus 2. Since they do not have anything else is common, both of them are giving me the same number in common, I take that common, I get x square plus 1. When I equate this to 0, from the first part I'll get x is equal to 2, from the second part I'll get x square is equal to minus 1. X square equals to minus 1 is not a real number. Whenever your graph is intersecting x-axis, that means there's a real number. Okay, x square is equal to minus 1 is not a real number, so that's why x equals to 2 is the only point at which your graph will intersect x-axis. So option B, 1 is the correct answer. Alright, now from the next question onwards, I'll do with you in the next class. Just before next class, go through your notes of SAT Math Lecture 1 and Lecture 2, wherein you studied remainder theorem, factor theorem. Okay. Also, if possible, just go to this website before my next class, desmos.com. On this, go to the graphing calculator and just observe, take any function. Let's say f of x is equal to sine x. Okay. Observe what happens when you do f of x plus a, when you do f of x minus a, when you do f of minus x, and when you do minus of f of x, and when you do f of x plus a on the outside and f of x minus a on the outside. Just see what each of this does to your graph. This two observation would not be very evident in the sine graph. Instead, take f of x is equal to mod x graph. A can be any number. Just keep on trying with different numbers and see, because this will help us understand how does a graph move with different translations, which I'll discuss in the next class. So this is one activity that would be good if you try before the next class. Second thing that you can do before the next class is just go through your notes on remainder and factor theorem. And one question to think about, suppose there's this graph. Okay, this point is minus 1, this point is 1, and this point is 3. Is it necessary that equation of this is x plus 1 times x minus 1 times x minus 3, or it's not necessary? Okay, just have a thought on this. I'll tell you answer to this in the next class. Okay, because that forms an important part of our next class. In the next class, we'll be looking at translations of the graph, some questions based on factor and remainder theorem, followed by a review of complex numbers. Once all of this is done, we'll be looking at the last part, some more math topics like geometry and trigonometry, which can be asked in SAT Math. Keep your calculators handy, because for trigonometry, for some questions, you'll need calculators. That's it for today's class. Unless you have questions or queries, we are done for the day.